What shape does this remind you of? Starts with a P.
Parabola.
Parabola. During what years is it decreasing? From when to when? 1996 to what?
2004.
What years is it decreasing? Going down?
2001.
I think 2000.
2000, because if you look at the graph, it goes from 17.2 to 17.3.
Yeah, that's the lowest. Okay, good.
It's very close.
What years? Oh, sorry, the increasing. Sorry, the increasing was first. So the decreasing is 1996, the bottom part, to 2000. During what years is it increasing? From when to when?
2000 to 2004.
2000, 2004. Okay, focus on those parts in. What's the meaning of the vertex in this context? So the vertex,
We skipped one.
oh, sorry, approximate, what is the vertex? So the vertex is approximately 2000, comma, 17.1.
It was 17.2.
Thank you.
Were you getting that from on the left here?
You're getting it from the graph.
The
So
chart.
I find it right here.
Oh, okay, yeah, the chart.
That's my vertex. Does everyone agree with me? My vertex is roughly 2000, so 2000 comma 17.2, the lowest point?
Yeah.
Okay, so what does that mean? What does 2000 stand for?
Here.
Here?
Years. Okay, so in the year 2000, what? The participation in the food stamp program was at its highest or its lowest?
Lowest.
Lowest.
You can't see it.
You can't see what?
Never mind.
Oh. Oh, you can't, the question? Yeah, you're right. But I'm just trying, so it's saying, so it was, so what is it, and then let's figure out the meaning. So the meaning, it's easy to get the meaning from this page. You're right, so David is correct. Here's the question here. Number 3, that I'm asking you folks about now. What's the meaning of the vertex in this context? And my question to you is, what does that mean? So is it a maximum or a minimum? Write that in there. And then what is it? So food stamps participation reached its whatever in whatever. So food stamp participation reached its, and then is it maximum or minimum, fill that in blank with blank percent. Fill in those blanks. What do you think they are? Food stamp participation reached its maximum or minimum. Which one is it?
Oh, that's percentage.
Isn't it percentage? Is it not?
I don't know.
No,
Oh,
it's
in millions.
No, millions.
Oh,
Yeah,
sorry.
People, I just put
With-
people.
With blank million people. There we go. Thank you. I was guessing. Okay. Has everybody filled in these spots?
So I wrote it a little bit different.
That's okay. Fill in those spots. Is this a maximum or a minimum? Write it in there.
maximum? Does it go along with, that's the maximum? Okay.
My brain is not working today.
And then was, what year, and put any vertex in
All right, so the data above can be modeled with this equation. Where t is the number of years since 1996. Find the vertex using the equation. So that means we're going to have to find h and k. H equals, figure out where my h equals, and then figure out what my k equals. Right, negative b over 2a. I'll let you write it down. Write down negative b over 2a. Fill those blanks, find it. Okay, minimum
Line all of this,
in
oh.
2000
Operation, we're gonna do exponents first.
was 17.2.
Times 4.225.
So my h is going to be negative b, which is negative 3.929 over 2 times 0.456. And when folks did that, they ended up making a positive 3.929 over 0.93. Okay. And what'd you get when you got this? 4.225, I believe.
Yeah, 4.225.
Okay, great. So now we're going to stick that back into our main equation. So then my k is going to be 0.465 times giant parentheses squared minus 3.929 giant parentheses plus 25.718. What goes in there? My h, 4.225. And did folks do it piece by piece? Is that how they did it?
That's what I did, yeah.
Okay, do you have the in-between pieces?
If I did them right, yeah.
Okay, so what did you get for the first part?
8.301
8.301 minus?
minus 16.600. So I was just rounding to 3 decimal points.
Yeah.
And then-
Okay, so is that what folks got, kind of? Yes, no? And the very end, ended up with 917.419.
Yeah, that's what I got.
Is that what everybody else got? No?
Yeah.
Yes? Okay. All right. If you not do it piece by piece like this, and I think it's the easiest way of doing it. Were you close with your, were you like
Yeah,
17.42?
I was 17.418.
418? Oh, yeah, that's fine. Yeah.
Yeah.
Yeah. If you end up rounding, if it rounds up to 17.42, then you're fine. That's, if you end up with 17.4, that's fine. Does that kind of make sense? You're in the right ballpark. Okay. Good deal. Is that approximately the same as the vertex of the graph? Yeah, well, the vertex of the graph was 17.2, right? So yeah, pretty close. Yeah, the vertex of the graph was 17.2,
Yeah.
right? So that's pretty close.
So that would be a problem. That would,
And then you just subtract and add all.
What would you-
17.
how close would you consider pretty close? I mean,
I don't know. I mean,
Well, we also got a little bit extra on the years, so that would make up for the little extra. Because we
oh,
got,
right,
we got 4 years, 0.2
Right.
past instead of just 4 years past.
exactly. Yeah, because the year is 2000.225. So it'd actually be a little bit past. It's not quite accurate there either, right? It's a little past. So yeah, that seems totally reasonable. Okay, so we are done with that one. And next, we're going to take a look at factoring strategy. Oh, this is a good one. Okay. Excellent. What are we gonna do this for? Okay, so factoring strategy. This is just a real basic, general strategy for factoring.
We're gonna get the cameras on.
Too small. Whatever, that's fine. Okay, so first, the very, very first thing you should do is factor out the greatest common factors. So figure out what you can pull out of everything, every single, so what you'll have is you'll have terms. Do you folks know what terms are? They're where you have things being multiplied together, separated by other things being multiplied together by pluses or minuses. Okay, so factor out the greatest common factor. So figure if there's anything you can pull out of all of your terms, because that'll give you smaller numbers and it'll be easier to work with. Then, figure out how many terms you have. If you have 4 terms, in this class, if I do something with 4 terms, it's going to be factored by grouping, which we're going to go over in a minute. If it's 2 terms, you should look for a difference of 2 squares. And we'll go over that later on as well. But if it's 3 terms, that's where you kind of are going to be looking at trying to do like a diamond. Has anyone heard of like the AC method? Has anyone heard of that? Or the diamond method?
It's also called like an area model.
Area model?
That's the term the other professor uses.
Okay, area model. So we'll take a look at kind of those options. So this is mostly just, here, hand this one out too. This is mostly just a quick overview of which things, what you should do. And then, after you do that, see if you can factor again. Because sometimes with this difference of difference between 2 squares, you can factor out again a little bit further. So now, we're going to, so this is just sort of your general overview of when should you try to use each of these methods. And now we're going to look at the methods themselves. All right, so this is some review that might be new, it might be old, I'm not sure.
Well, we're not doing anything on this page then, right?
No, that's just that's kind of a reference for you to use later on, so you can figure out what to do with things. The key thing to remember from that sheet we just did is that if it's 4 factors, it's going to be factored by grouping, which we're going to go over in just a couple minutes. So the first is, though, first thing, always figure out what you can pull out of everything, greatest common factor. So for example, 18, 24, and 48, they all are multiples of 6. So I can pull out 6 out of all of them. For variables, think of it like this. Here, how many x's can I pull out of here? 2 out of there, I can pull 3 out of there, I can pull 4 out of there. So what's the most I can pull out of all of them? 2 x's. So I take 2 x's out of everything. How about numerically? I've got a 2 and I've got a 3, so I can't pull any numbers out of there. Is everybody sort of on board with that part? So let's do some examples.
The number that you pull's gotta be, they go into the whole group.
Yeah, everything.
Greatest common factor of everything.
Yeah.
Oh.
Okay, so the
Take
first
step
one,
by step.
what can I pull out of x cubed and 4x squared? Well, numerically, there's no numbers I can pull out. Because I just have a 1 here, so I'm okay with that. But what about my x's? What x's can I pull out of? How many x's can I pull out of both of them? What's the most number of x's I can pull out of both of them? 2. I can pull 3 out of the first one, 2 out of the second one, so the most I can pull out of all of them is just 2. Everybody with me? So I'm going to pull 2 x's out of all of them, x squared. So if I take x cubed divided by x squared, let me do that. Divide by x squared, divided by x squared. So I'm going to pull that out and put it in front. What am I left with? X cubed divided by x squared is what?
X.
X, yep, plus 4 x squared divided by x squared is just 1, so it's just 4. Did folks see where I got that from, or not? Should we go through that slower or differently?
Yeah.
So what I do is I take each, whatever I'm pulling out and putting in front, I need to divide each of these pieces by that because I'm multiplying it in front instead of where it's at. So I can take x cubed divided by x squared, I get x. 4x squared divided by x squared, I get 4. Feel free, do you have any other tips or ways that people describe it differently or better?
What a lot of students seem to get is because when you get the problems on my open math, it's usually like A, B, and C that you have to factor out. You can think of it as, like, for X, you'd be like, I have, first group has 3 xylophones, the second group has 2. How many xylophones can you take from everybody without taking too much?
Right. So,
Or you could use like apples, bananas.
I hate to do that because I like to think of it as actually having 2 apples. So I think of that as being 2x, 2a, you know what I mean, is 2 apples versus
Yeah.
$2. That's interesting. Yeah. All right.
I guess the part I'm not understanding here is with the x2 and x3,
Mhm.
2 does not go into 3.
No. Okay, so remember, this is x divided by xx.
Oh. And then
Right.
you just cancel. Okay.
Yeah.
Oh, okay.
Right. So this is x cubed, x multiplied by itself 3 times, not 3 times x. That's not 3. You know what I'm saying?
Oh, so that's what you're doing.
Yep. These are all multiplication. So how about here? What number can I pull out of both of these? 25 and 10.
5.
5. Okay. How about x and x to the 5th? How many x's can I pull out of both of them? Just 1. Good. Okay, so 25x divided by 5x. Would that actually help if I did it like that? 25x. Is this more confusing or is this less confusing if I do it like that? Is that more confusing?
Yeah.
Okay. And we won't add that in there. Okay. So 25x, if I pull a 5 out of there, if I pull 5 out of 25, I'm left with 5. If I pull x out of x, I'm left with 1.
It's 5x.
It's just 5.
Oh.
Because if I pull 5 out of 25, I'm left with 5. If I pull x out of x, that's just 1. X over x is just 1. Minus, if I pull 5 out of 10, what do I have?
2.
2. If I pull 1x out of x to the 5th, how many x's do I still have multiplied together? 4. Does it? Maybe I'll do it over here. 25x over 5x. Is that better?
Mhm.
So then these go away,
Yeah.
and this becomes 5 on top. And then the other part over here, 10x to the 5th, x over 5x. These go away. This leaves it, I'm left with a 2 up here, so I have 2 times x to the 4th. Next one. What can I pull out? What can I pull out of both of these? 8. Yep. Okay, here's the second part. I want my first number, what we call my leading term, to be positive. So I'm going to pull negative 8 out of this. Are folks okay with that idea? So I'm going to pull negative 8 out of this. How many A's can I pull out? 2. How many B's can I pull out? 1. Great. So negative 8 times what gives me 32? Oh, we'll do it that way. Negative 8 times what gives me 32? 4. And then a squared times what gives me a to the third? A. And then b times what gives me b? B times 1. So I'm good with that.
So you didn't write it like that, but you're just underlining, putting the whole thing underneath each one of those terms, right?
Yeah.
Yeah.
And kind of I'm dividing them by all of this. And then, this next one is interesting. So if I take 8 and divide by -8, what do I get? -1. If I take a out of a squared, I get 1. If I take b out of b squared, I get 1. So the key thing to remember is this, I want to take a look up. This is the same as that pretty much. So in C, yes? 8a squared b. This does not go away. There's still a 1 there. So don't forget the 1. Do you see what I'm saying? Because if I forgot the 1, and I just left it at 4a, then when I multiply this back in, I've only got 1 term, and I should have 2 terms. So what am I talking about? So don't forget the 1 there. It matters. Otherwise, it would totally go away. So if you start with 2 terms, this should also have 2 terms in it. Good? All right. Okay, so that's that first part. Let's take a look at factor by grouping. Grouping. Who's ever done factor by grouping? I had never done factor by grouping until I got to this class. This is kind of how I like to think of it. So I kind of think of it like a mustache. Here's my first part, first 2. Circle the sign, and the last 2. Or like a little cat's nose. So kind of like a little cat mouth, cat in the nose and then the mouth. So now I'm going to say, what can I pull out of both of these first 2 terms? Just the first 2. What was that? 5x to the second. Great, so I'm going to pull out 5x to the second. What am I left with? If I pull 5x squared out of the first one, I'm left with x, good. And then plus, what if I pull 5x squared out of the second term, what am I left with?
2.
2, great. Do not forget the plus. It's important. Where that little nose is, that's why I circled it. It's important. Look at the second part. What can I pull out of both of those? 7. Great. If I pull out a 7, what am I left with? X plus 2. Now, if you've done it correctly, this part and that part should be the exact same thing. Everybody look up for a second. The x plus 2 is in both of them. So I have something times x plus 2 plus something times x plus 2, which means I can factor out the x plus 2. So now they're both being multiplied by x plus 2. If I can factor that out and say, okay, x plus 2, what am I left with? 5x squared plus 7.
What are you foiling or something? Or how are you
No, I'm saying they're both being multiplied by this. So kind of think of it as being a. If I had 5x squared times a, right, plus 7 times a, I can factor the a out.
So you're condensing, you're just dropping one of the x plus 2s.
No, I'm not dropping it out. I'm factoring it out. It's in both of them. So I can factor it out of, just like I factored the 5x squared out of both of these 2, I'm saying that this piece, x plus 2, is being, I kind of have 2 big terms here in a sense. I have 5x squared times something plus 7 times something. And those somethings are the same. I can factor them out. So, I can think of it as 5x squared times a plus 7 times a, if a was x plus 2. So I can, since they're both being multiplied by whatever that thing is, I can factor that out of both of them. Okay, so let me do it this way. Just say this is just something red. That might have helpful. All right, so this might be a little bit complicated for folks. Oh yeah, I told you that you go. Let me just finish this part. So here, now we're done. Because this is getting pulled out of both of this larger sections. We'll go over it again. We'll go over it more next class. But that's the factor by grouping. Because they both have the x plus 2 factor in them. You factor it out of both of them.